Okay, so enough hand waving and intuition and depiction of the integral, and let's get to the thick of it. How do you calculate this kind of integrals? Okay, so I'm going to give you the step-by-step calculation of the integral along a curve of f, which is usually just a function of position, such as a force field, dot dr. So how do you calculate this? So remember that our curve C will be some curve in space with a starting and an ending point, and the vector field F will be some vector field that you can represent with arrows at each point in space, yeah? And they can be changing direction and so on. So now this integral of f dot dr will evaluate the vector field at every point along the curve, do the dot product with dr, and add it all up. Okay? So step 1 is going to be parameterize the curve. This is identical to what you were doing in the previous types of integrals. So you find a vector r, which is a function of u, which is x of u, y of u, and z of u. And you find the limits of u between a and b. The only difference with respect to previous integral FDL is that the direction of the integral matters. Okay, so let me write it down. The direction matters. Very good. So by direction I mean that if the parameter u is increasing from A to B, this means that you are moving from one end to the other in this direction, assuming that this corresponds to u equals A and this corresponds to u equals B. Okay? Very good. Next step is to find the dr vector. And I already told you there were 3 ways of doing it. Look it up on a table. Two, use geometrical intuition. Which usually involves using the dl that you already knew from geometrical intuition and adding the unit vector t hat. Okay, sometimes that can be done directly by geometrical intuition. Or 3, you can calculate it. And the calculation was very easy because you know that dr is simply the derivative of r with respect to u times du. Okay, and this is a vector. Excellent. Step 3 is to evaluate the integrand at the curve. And this is the step that is different for this kind of integrals, right? Because you have to evaluate f dot dr. And this involves several things, actually 2 things. So first, substitute x, y, and z, or we could write it as substitute r of u into f of r. Yeah, so remember, x, y, and z, let me write that, r of u, which means x, y, and z. So substitute that into f of r, yeah, which we write mathematically as f of r, we change it to f of r of u. That's mathematically how we can mean that we are substituting the parameterized curve, r of u, we are using that to substitute into r. So every appearance of x, y, and z in the vector field f, we have to substitute it by the corresponding function xu, yu, or zu. Okay, so that's one thing you have to do. And the other thing that please never forget is to do the dot product. Similar to when we were calculating the flux, right? Do the dot product. Please don't forget that. So the dot product is this dot product here. Yeah. So you must have a vector here and a vector here, and therefore you have to do the dot product and arrive at a scalar. Okay? So let me write it. By the end of step 3, you should have, so the integrand should be a scalar function of u only. Plus constants. So 2 things are important. It must be scalar and it must be function of u only. Okay? So always check that before starting the integral. In other words, we could say that f dot dr must become some function of u times du, and this is a scalar. Okay? So step 4 becomes then very easy. You calculate the integral. So you have the integral over the curve of f dot dr becomes the integral in u of g of u times du, from u going from a to b, which are the limits of the curve. Okay, and this g of u was the result of doing these 2 things: substituting the curve into f and doing the dot product. Okay, excellent. The way in which books will write this, they will write it like this. So they will say that the integral of f dot dr is equal to the integral of f evaluated at r evaluated at u. Yeah, so this means substituting the parametric equation of the curve into f dot. So normally books will write directly dr over du. They will write this here, dot dr over du times du. Okay, so this golden box includes all of the steps in a single equation. Okay, so just either remember the steps, or once you become an expert, you have calculated several of these examples, you just have to remember the equation and apply it. Okay, great. See you in the next video.